Hi guys, today in class we did some justification of correct equations, and so if you missed that in class or you just need a quick refresher, here's just a quick video on the 4 examples that we did in class today. So the equation is on the left hand side here. We did the first equations, and then you need to describe the mistake if there is one, and then the correction or the justification for each problem. So while I'm going through these, my personal method is to just go through each step of what they've done. So from here to here, I'm trying to see what's different in both equations. All right, or what's different in the equations. So I've noticed right away that 55 becomes 11, and then on this side of my equation, my 5 is actually gone. So what that tells me is that on this step here, this person divided both sides by 5, okay, which is justified, all right, because this is 5 times 2x plus 1, excuse me, and to get rid of that 5, we do undo it by dividing by 5. So that is correct right there. And then I'm going to look at the next step here, all right, from here to here. All right, that 11 changes to a 12, and then on the left side here, the plus 1 is gone. So I know that on the left side, we subtracted 1 from both sides, but on the right side, we added 1 to both sides. All right, when we do something different to both sides of the equation, it actually changes the equation. And we could even go back in and check that number 6, and we're going to find that we're going to get the wrong answer. So this is where our mistake is, all right here, okay? So describe the mistakes in words. I would kind of put here in step 2, all right, the evaluator, that would be you, did not do the same operation to both sides. All right, and that changes our equation. Let me hit our select tool here so I can make this smaller. Maybe I can't make that smaller, but that's okay. All right, so that's kind of where we go from here. All right, that would be a good explanation. All right, the correction or justification, I want you guys to actually go through the problem again and do it all correctly. So 5 times 2x plus 1 equals 55. All right, remember the first step they did was correct, so I'm just going to go ahead and divide both sides by 5. All right, cancels over here, so I get 2x plus 1 equals 11. This is where they went wrong. So instead of subtracting 1 on both sides, they accidentally added 1 on that other side. And we're actually going to get 2x equals 10. And then we can divide by 2. All right, and we are going to get x equals 5. And if I check my answer over here, 2 times 5 is 10, plus 1 is 11, and 11 times 5 does get me 55. So I do have a correct answer right there. Okay. Take a picture of that so you guys can see it later. And I gotta erase some things over here so I can work in my other space. All right, so we got x equals 5 in that one. Let's check the next one here. Just kind of going step by step through exactly what our process is again. All right, in step 1 here, they kind of split up the x's into x plus x instead of 3x, and then they did it on the other side as well. 2x is split up into x plus x, but we did keep that plus 20 on the right side of the equation. And then on both sides of our equation for our next step here, all right, they did cross out the same number of x's. So if they did the same thing to both sides, then we're still in the clear. So far, this step is correct. All right, and then we get x equals 20. So I haven't found anything incorrect in either of my steps, but we can always check our answer. So 3 times 20, is that equal to 2 times 20 plus 20? All right, 3 times 20 is 60. 2 times 20 is 40, and then don't forget that plus 20, and then 60 equals 60. So that person or that evaluator did everything in their steps correctly. Cool? All right, let's move on. All right, in our next question here, we're doing exactly the same thing. We're going to go through it step by step and see if they did anything wrong. So in the first step here, I noticed that 7 becomes 10, which means I add 3, and then they got rid of the minus 3 over here, which at first thought looks like they added 3 to both sides here. However, if I had added 3 on this side, right, I would have actually got a bigger number because this 3 is over a 6, which means that I'm actually subtracting 3/6 from 5x over 6. So I've actually added too much over here, and that's going to be our mistake. Okay, so our mistake is that the evaluator added 3 when, oh man, this is going to mess me up, when they should have added 3 over 6, okay, because that is actually the number that's over there, right, not just 3, but 3 over 6. So, and that gets kind of tricky with fractions. I just want to move you, thank you. So let's do it correctly. All right, I might need a little space, so we're going to kind of scroll down to the next one here. And my handwriting on the computer is quite large, so that's why I've got to do that. So 5x minus 3 over 6 equals 7. What I would do first is just get rid of that fraction by multiplying by the denominator, so multiplying by 6 on both sides. So that cancels over here, and I get 5x minus 3 equals 42. All right. And then I can add that 3 to both sides. That makes things just a little bit easier. Cancels over here. I get 5x equals 45. And then divide both sides by 5. I get x equals 9. All right, so that would be our correct answer instead of that x equals 12 there at the bottom that we got. All right, cool. So this next problem, sorry, I gotta erase some things over here just in case. So our next problem is actually set up pretty visually. And so what that is doing for us is we're just, instead of having to write it all out, we're kind of combining it into these what we would call algebra tiles. And this is like really helpful for those of you who think in visual, you know, with images and stuff like that. So we've split it up into our x's are like little separate algebra tiles, and then our numbers are going to just be that combined algebra tile there. So this, from step here to step here, we just split them up. All right, I have 4 x's on the top, I've got my plus 8 there, and then I got 5 x's on the bottom, and then I've got my 3 right there. Okay, and so now from here to here, I just want to make sure, did we do everything correctly? All right, we've got some x's here. All right, and these x's line up, and then I actually split 8 into 5 and 3, which I can do because 5 plus 3 is 8. All right, and so what we're doing here is we're actually going to be able to cancel things out. So watch, these x's go away because they are there, right? And then the 3 and the 3 are the same, so they can go away. So what I have here, and remember these are on two separate sides of the equals, is x equals 5. And just in case I want to test that, make sure they did anything or didn't do anything incorrectly. All right, I'm going to plug it in. All right, so 4 times 5 is 20 plus 8, and then 5 times 5 is 25 plus 3. I'm going to get 28 on this side, and I'm going to get 28 on that side. So for number 4, they did nothing incorrect, and this is going to be a good model problem for you guys when you do the next couple of visual tile problems there. If you have any questions, send me an email. This was done in class, so if you need more help, then I can send you the Zoom link as well. Otherwise, have a good afternoon.